Hello and welcome everyone. My name is Onur Uygun. I would like to introduce myself briefly first. I completed my master's degree in 2020 in chemical engineering at Marmara University. Currently, I pursuing my doctorate degree in chemical engineering also. I work at Research and Development Department in DO Paint Corporation as a research and development engineer. And today I will talk about my master thesis study, which is about surface characteristics and flow dynamics of microchannels coated with polyurethane and epoxy resins. And first of all, I would like to share the agenda of this presentation. At first, I will explain the aim of this study. Then I will share the theory behind this study in brief. And I will continue with what we had done and what is achieved as a result. And I will finish my presentation with conclusions of this study. Lastly, we will take your questions, but it's not possible for me to join and answer your questions online. But either my advisor, Professor Emin Narca, will join to answer your questions, or even if he couldn't, I will answer your questions later and contact you via email. So we had three main targets in this study, which are developing experimental setup, developing a software, and last but the most importantly, our aim is comparing surface characteristics parameters, which are dynamic interfacial tension, friction factor, and surface free energy. So if you look at the theoretical background of this study, as most researchers in this field would know, we can say that the main or the fundamental part of surface free energy determination is contact angle measurement and the three-phase equilibrium equation of Young. After this, dividing surface free energy into different components is one of the key milestones in this field of research done by folks. And then Berthelot's hypothesis of adhesion and cohesion work comes, which he explained the main variable, which we cannot measure or determine by experimentation, which is interfacial tension between a solid and liquid. He said that interfacial tension between solid and liquid is a function of surface free energy of solid and surface tension of the liquid. So after these main, let's say, discoveries, there are several efforts for determination of surface free energy of solid materials. These are the most used calculation methods, mostly used calculation methods. Details are given in the paper, so I will continue with this presentation because of the time constraint. And for flow characteristics analysis of microchannels coated with polyurethane and epoxy resins, we used the Reynolds number as a main parameter, as it is the main parameter of almost all flow analysis. And another parameter is, which we investigated, is friction factor. We used Darcy's friction factor in this study for laminar flow because we done our measurements in laminar flow. This equation is known as valid for both microscale, miniscale, and microscale systems. So Washburn's analytical solution for capillary flow through circular channels is a foundation for current investigations. Washburn examined a horizontally oriented straight circular capillary tube to model fluid flow in circular channels by accounting for dynamic contact angle. He used Hagen-Poiseuille equation and Young-Laplace equation to model the fluid flow in this system. Schematic representation of our system is given in the figure at the bottom. So what we did in the study is we utilized Washburn's analytical solution for capillary flow to determine interfacial tension between coated inner surface of the channel and the fluid flowing through the channel by combining Washburn's equation and our fundamental equation, Young's equation. We combined these equations, and then we developed a new equation. At the bottom, you can see our new equation in red square. The unknown variable in this equation is interfacial tension between coated inner surface of channel and liquid flowing through this channel. All other parameters are known or measured. So finally, we can calculate the interfacial tension between coated surface, inner surface of channel, and fluid flowing through that channel. And we use two different coating materials, which are polyurethane-based coating and epoxy-based coating. Synthesis and detailed explanations of these coating materials are given in the paper. So I will again continue my presentation. And here we want to share our testing liquids, and the surface is coated with polyurethane and epoxy resins. On the right hand side, it's our film applicator, which is also developed by our laboratory team. This is the schematic representation of our experimental setup, which we developed in our laboratory completely. The component indicated with H is H refers to the sample to be analyzed, which can be either a microchannel coated inner surface with coated inner surface, let's say, or a flat solid substrate, I can say, coated with coated surface. We used LabVIEW to control all these devices via our computer. On here are our image-based measurements. You can see on the left-hand side there are pictures of droplets on the coated flat surfaces, which used to measure static contact angles and then calculate surface free energies. On the right-hand side, there are images of superimposed snapshots from recordings of fluid flow through our coated channels. We use these images to measure dynamic contact angles and calculate fluid flow velocity, and then, of course, the interfacial tension between the coated inner surface and fluid flowing through this channel. These are the two parts of the calculation surface that we developed, which is consisted of 665 lines. Upper part shows the data library of measuring liquids used in the study, and below it is the part of surface free energy calculation algorithm of Fox methods. So these are our final results. I mean, the summary of all calculations and measurements in this study. First 5 parameters are measured by experimentation, and last 4 parameters separated by dashed line are calculated by our software. Firstly, we made static contact angle measurements, and the static contact angle values showed that polyurethane coating was more hydrophobic because the contact angle of the water droplet on polyurethane coating was higher than the contact angle on epoxy coating. This was an indication that surface energy of polyurethane coating will be lower than the surface energy of epoxy coating. As expected, the surface energy of polyurethane coating is lower, as you can see. So accordingly, it was expected that the friction factor of polyurethane coating will be lower than the friction factor of epoxy coating. And parallel to this, the dynamic contact angle in polyurethane coated channel will be higher than the dynamic contact angle in the epoxy coated channel. So it is seen that the contact angle between the fluid, which is water here, flowing through the polyurethane coated channel, and the polyurethane coating is lower than the contact angle between water and epoxy coated channel surface. Although this result is the opposite of the expected result, it is concluded that this is caused by a higher flow rate in polyurethane coated channel, because the dynamic contact angle depends on the fluid flow rate. So let's continue with our calculated parameters, which we will use in comparisons. Reynolds number for both flows are below 10. Both flows are laminar, of course. This is important because we want a stable flow for measurements. For other parameters, it can be seen that all these surface free energy, friction factor, and dynamic interfacial tension values are higher for epoxy-based coatings. So all these values were plotted for polyurethane and epoxy-based coatings on a logarithmical scale to visualize these comparison. Overall 3D graph of friction factor, surface free energy, dynamic interfacial tension for polyurethane and epoxy-based coatings showed that there is a certain relationship between these parameters. It can be seen that values for all these parameters are increasing in epoxy-based coatings. After seeing this graph, we decided to investigate these parameters relation between each other separately. So we decided to make these comparisons between surface free energy and friction factor, and dynamic interfacial tension and friction factor. So this is the 3D graph of comparison between dynamic interfacial tension and friction factor for polyurethane and epoxy-based coatings. And the graph revealed that there's a possibility that there may be a certain ratio between these parameters that can be described mathematically. Therefore, the possibility was investigated by dividing the logarithms at the base of 10 of these parameters. The results show that the friction factor and the surface energy ratio did not show that there is a constant ratio between these parameters. Maybe we can investigate this further, but on the contrary, the ratio of friction factor and dynamic interfacial tension for polyurethane-based coating is approximately equal to the ratio for epoxy-based coating. It can be said that there can be a constant ratio that equals to 0.36 between friction factor and dynamic interfacial tension for a certain flow velocity, and if the flowing fluid is water. Even though this is an exciting result, this ratio should be examined in more depth by conducting experiments on on channels with different coating materials. So lastly, I would like to summarize our contributions. In application category, we developed an experimental setup for measurements of static contact angle, dynamic contact angle, flow velocity, and differential pressure. Also, we developed a calculation software to calculate surface strain energy with different methods, and Reynolds number and friction factor, and finally dynamic interfacial tension. And scientifically, we developed a new equation and we defined a new term, which is dynamic interfacial tension, and which is defined as interfacial tension between a coated inner surface of a channel and a liquid flowing through that channel. Also, we found that there can be a constant ratio between friction factor and dynamic interfacial tension, which is equal to 0.36. We have also some recommendations for future work, like automation of sampling, integration of experimental setup with calculation software, and in-depth investigation of dynamic interfacial tension, and investigation of constant friction factor dynamic interfacial tension ratio, which is 0.36. We should investigate this this ratio with using different coating materials, like I said. So thank you for participating. This is the end of my presentation. As I previously mentioned, your questions will be either be answered by my advisor, Professor Emin Arca, or they will be answered by me later and sent you via email. Thank you all.